I'm Dorota. I work in such a lab at the McGavin Institute. So today we will talk together with Jarek and Sacha about the containers and what kind of issue you might have with them if you want to really use them in your reproducibility work. Next one. Okay, so I will start from the introduction about containers, and later we'll be talking about the ReproNim tool stack and how to connect all the pieces. Okay, so in terms of containers, if you want to ask question, what are they and why do you use it? So that's basically like standardized self-contained units of software that can be run anywhere. And if you ever used or heard about virtual machines, the goal is more or less the same, but containers are much lighter, and that's why they gain popularity within in recent years. And if you talk about container technologies, people mostly talk about Docker and Singularity. For some reason, Jarek, I cannot see all the entire slide. So is it just me?
Presentation mode for you. Okay. Does it appear now?
Oh, yeah. Yeah, sorry. I don't know what is it. Okay. So basically for Docker, so one technology is Docker, and it's probably most well-known technology that is available on the market. It works on Linux, Mac OS X, and Windows Pro. But unfortunately, it is not supported by HPC centers due to some problem that it can escalate privileges. On the other hand, you have like Singularity, that is a solution that was designed specifically for scientists and can be used by traditional HPC centers. Next one. So, in our groups, we love using containers, and we think they are great because, as I mentioned before, like they can isolate and encapsulate the computational environment, and that gives you much better control on your work environment. In addition to this, they provide a standard method to create and share the environment, and that might be extremely useful when you collaborate with people that have access to different machines and you don't want to install everything for them. It also runs on various operating system, basically on Linux, Mac OS, and Windows. So it really simplifies the changing of the hardware if you need to. And in addition, it's because they're like isolated and encapsulated environments, they actually, the environment doesn't change with time, and that really can ensure the execution of your work. And this way is the first step for reproducibility. So, so I think like containers are a really great solution, and in theory they are like pretty much perfect, but in practice there are like few issues that we need to think about. So I told you before that like because they're like isolated environments, they should ensure that you are able to re-execute your workflow and have the same results. But if you are using Singularity, it actually the default settings allows for leaking some of the environment inside, and that can affect your results. It also, even if we argue that containers are pretty easy to use, they're not necessarily easy to create Docker file or Singularity file that contains the recipe how to create the image and containers. Because like one of the issues is that actually like containers themselves are not necessarily reproducible. Because if we don't pay attention to and do not specify all version, the container that I'm creating today from the recipe, it might be different than the container you will be creating in like 2 months. So that's an important issue that you have to keep in mind. Many people, because they don't create their own containers, but they are using containers that are available in hubs. But the other issue with this is that we cannot really like be sure that these containers will be available in future. And the last issue is that, as I mentioned before, Docker is not used at the HPC centers. On the other hand, Singularity, it only works on Linux and does not support OS X and Windows. And you can read more on the poster that we provide the link. So as I said, like one of the issues is like that the writing recipe is not necessarily the easiest thing. So and NeuroDocker is the tool that actually can really simplify this process. It supports popular software distribution, and it provides custom recipes for popular neuroimaging softwares. So it basically makes your process of creating image much easier. And it also incorporates the best practice and allows you to minify existing Docker image, because the size of the Docker actually might be an important issue as well.
And there are examples, right, which
Yeah,
are
exactly.
available also within GitHub repository. And now we will get to this wonderfully complicated figure to explain additional kind of aspects of all this procedure. So NeuroDocker helps us a great deal with specification, creating the specification or recipe for creation of the container, which later on would be created either locally or on Docker Hub, Singularity Hub, be created and stored there somewhere in the cloud. And we provide additional tools and support. Let's say there is ND-Freeze tool. As Dorota mentioned, containers are not necessarily reproducible themselves, right? So you run the script today, and tomorrow, maybe within the same day, you'll end up with different container content because maybe underlying operating system like Debian acquired new versions of the package of the packages, and it will install newer versions while leaving you with the um, different container from what you had before. To resolve that, we provided a tool which is called ND-Freeze after NeuroDebian Freeze, which freezes app sources from Debian and NeuroDebian repositories, so you have better chance to generate exactly the same container content from run to run. And it's quite simple to use, and it's supported by NeuroDocker. So you just specify the date for which you want to create that container. And that also opens the door for reproducing environments others potentially used. If you've heard that, oh, these people did their analysis in an environment which was based on Debian or NeuroDebian, and it was established somewhere last July, you could easily create a recipe which will take those July versions from Debian and NeuroDebian and create likely really similar environment to what they had before. So that's one of the tools which helps with specification and creation. Another tool which we'll not talk in detail here, but which is in development, is ReproNim, and it provides facility to execute computation on your data sets uh, in the cloud. So you might have your data set locally, and then you're just prescribed that, okay, I want to execute that computation using these containers somewhere, let's say in Amazon EC2 instance. And what will happen, it will upload only necessary components, and the rest of the components will come from somewhere in the cloud if they're available. Let's say data sets would come from OpenNeuro. If we integrate somehow with SchizConnect, they would come directly from SchizConnect instead of doing the dance through the user's laptop. So it just empowers users to run computation without requiring them to have a copy of all the data locally, but while keeping a good provenance about what was done. And in the next slides, we'll talk about Yoda principles and a little bit more about data lab. So what is Yoda principles? Uh, I even forgot what abbreviation stands for. It's yet another organigram on data analysis. Um, and the principles are simple. What we want is to create computational environments to compute analysis results, and that's pretty much those containers we talk about, but also exhaustively track all analysis inputs in the same version control system. So you shouldn't use pieces from all kinds of locations to achieve tracking, but you could use the same version control system to track it all. And in our case, it's Git and Git Annex and data led on top of it, where you could track everything. You could track code, scripts, data, and the computational environment's images, be it Singularity or Docker. But also another important aspect is modular organization. Let's say we have a data set from which we create derived data set. And the point is that derived data set should be separate entity, but it should have all information necessary to pretty much recreate itself from the original image. So that's where um, this modularity comes into play. But also each module should be usable independently. So you could take derivative data set and use it without pulling all the original data, which kind of was necessary to create it. And here is an example of suggestive Yoda dataset layout, which would also list this ReproNim containers dataset, which I'll talk about in a second. And as you could see, it's just regular kind of reminding bits maybe layout to some degree that we have analysis dataset, which internally links into fMRI preprocessed dataset, which in turn leads into bits dataset. And all of those are separate entities in a sense that you could use them independently from each other. And also it links maybe into the containers which were used. And any of those pieces, upon demand, could become available on your file system. So if we go to the next slide, we'll get kind of bigger picture where you could have a paper data set which contains all your manuscript text and figures. But the point is that that paper data set is linked to the analysis data set, and the same analysis could be used in different papers. But that analysis data set in turn is linked to all the data sets which are necessary to produce that analysis result, such in this case, it's probably fMRI prep data set. And pretty much it's like all turtles way down, right? But every this kind of darkish box here is just separate data sets which just has information about its provenance, how it got there, and it's stored in version control system. But underlying pieces might come from different places. Let's say data in our case often comes from OpenNeuro, but also let's say in case of fMRI prep dataset, containers themselves could come either from Singularity Hub somewhere, or they could come from our dedicated containers dataset. So what is that containers dataset? To solve problem of possible disappearance or replacement of containers in the hubs, we just initiated a containers dataset where we keep copies of all BIDS applications converted into Singularity image because it's just single file, easier to track. We also track their ReproNim tools, and then we provide their a little shim Singularity command, which takes care about sanitizing environment which is used for execution, and even allows to run it on the non-Linux systems via Docker. So for a user, it shouldn't matter either running OS 10 or Linux. It will run that Singularity image through Docker if necessary. And also it takes care about all the bind points. As I've mentioned, dataset should have all sufficient information inside of it. So we don't even bind mount any external directories, which is another problem with just plain running Docker or Singularity, that you could just bind mount anything. And then there is no guarantee that anybody else would know what have you bound, like which directories, and be able to reproduce the result. And this data set is kind of already ready to be used with data-led containers run, which simplifies execution. So you could discover which containers are available and just say, oh, data-led containers run this container, and it will take care about fetching that container from wherever it's available. In our case, we keep copies of all the container images to guarantee their availability and exact version of those containers, because even the same version could change on Docker Hub or Singularity Hub. And hold on, there is a jump. And now we switch to Satra.
All right, so I'm just going to follow up on what Dorota and Yarek has said. We all know neuroimaging data have become richer with larger cohorts and greater variety of acquisitions. A lot of useful methods and many pipeline tools are available. Interpreting and comparing results and enabling reuse requires understanding provenance of these containers, how it's processed, how the data was generated. And to be useful, this provenance must be understandable and easily communicated and captured automatically in machine accessible form. You will hear soon, so I'm going to skip this, but my goal is to kind of end this presentation with the hard question. So you'll soon hear about NIDM as a model from Dave Keeter and Jeff. I'm going to focus a little bit on the workflow side of things of this model. Next slide. So within a workflow specification, or with the NIDM workflow specification, we can describe what a container did. So we captured the specification of the workflow and its execution using this model. But we actually get to an even harder question in the context of some of the things, and that's where we would love to hear about how do you think about process. So let's get to the last slide, which is, to me, a harder question. What does a container do? You have received a random container from the web. How do you know what it does? And we can take fMRI prep as an example. We know it pre-processes functional time series to a standard space. It may do realignment, it may do registration, it may do distortion correction, and it may extract quality measures. It may do some or all of them, but unless you're reading the paper, it's very hard to ask the container what it does. And as we build up these containers over time, while we have tools that allow easy re-execution and reproducibility, we haven't yet solved this harder question of what does that container do? We can also take FreeSurfer Recon All as an example. We know, as people who have used it, that it extracts surfaces, creates labels, volume surfaces, extracts statistical properties, removes bias, and registers to a common space. But we don't really have a good way of encoding this yet in a descriptive form that others can reuse. So in some ways, this kind of ties back to what Lei and Jess were talking about, what they're trying to do with data to harmonize things. We will need some kind of harmonization of these millions of containers that will be generated by people in terms of understanding what they will do. So with that hard question, I will stop there and let things move on.